Sir hails from 27th batch of BRC Training School. In year 2002, Sir published an integral in American Mathematical Monthly. Since then, this integral is well known as Ahmad's integral in books, encyclopedias, journals, and websites. One may Google it. Dr. Ahmad has been a great resource person in various mathematical Olympiads, including JMO for a very long time. In 2009, Sir took Team India to the Golden Jubilee Year of International Mathematical Olympiad IMO in Germany. Dr. Ahmed has been awarded the degree of Doctor of Science in 2009 by Mumbai University. Presently, Sir is delivering enrichment lectures on IIT JEE Maths and of course on Olympiad also. And let me tell you one more thing. Let's all first welcome Sir because Sir is a great personality. And for many years, Sir has been associated with Olympiad classes, with Olympiad program, and has taught many students. And let me share one more thing with you all that the success behind the success of these classes, which we are taking since last 2-3 days. Sir has played a key role. Many resource persons which we have contacted and Sir guided and suggested and arranged many resource persons. So thank you from the behalf of all of us. Thank you so much.
Thank you.
Over to you, sir.
Thank you very much for a kind introduction. Incidentally, in 1999, this was school number 2, where we started evening classes for the colony students. So we had the opportunity to interact the very bright students of colony for so many years. Okay, and before that year, let me also tell before that in 1999, when we started evening classes here, we were doing it in, we actually started in 98 or 99 in junior college for 11th standard students. And you know, your well-known, our well-known guy, Parag Agarwal was the first student. Then we thought it is better to conduct it in this school number 2. Okay, so you all have come here from all over India. DA. Oh. Yeah. Hello. Yeah. So you know this. So just raise your hands. 8th class students. Very good. 9th. And then 10th. Those of you who have come for JMO last year, can you raise your hand? Are you there? Are they here? JMO, yes. Just few of you. Why? That's all. I mean, or maybe, okay. So how many of you just raise your hands again? Okay, fine. And then, who of you have qualified for RMO this year? After RMO, yeah.
After RMO.
You wrote RMO? You qualified? No. Okay, don't worry, you'll qualify later. This process is every year. Okay? Okay, so you know, this one important, very interesting thing is that in this Olympiad activity, Maths Olympiad is the first subject Olympiad in the world. Okay? And it has got a property that it is very conservative. It just asks questions of 4 topics: geometry, algebra, number theory, combinatorics, and they don't ask. They leave every other thing. So the syllabus is very small, but the degree of difficulty is very high. So if you write, and these exams are unreliable. Okay, so if you write these exams, it's good to study, to practice. To write these exams, if you are selected, it's marvelous. It's commendable. If you are not selected, it is understandable. The exams are very difficult. And they are not patterned. They will ask one question like this, one question like this, one question. They are supposed to leave out some lot of topics. They are supposed to leave out logarithms. They are supposed to leave out trigonometry. They are supposed to leave out series, etc. So many things. But they do come. They do come sometimes. And in order to solve those questions, you might have solved a lot of series problems and logarithm problems and this and that. But in Olympiad, if they ask you a question where there is a slight tinge of what do you call it? This, like this, a logarithm or trigonometry or series or something. You may have solved a lot of problems, subjects, in lectures, whatever. But if they ask you, that means they will ask you something very essence of that. Okay? And very essence, somehow these things are missed out while teaching or while understanding, while writing books. These things are missed out. You will see how. Okay? So this one. So in these two lectures, I will be telling you the essence of algebra. Okay? Then parents don't understand this. Why these people they make sit 8th class, 9th class, 10th class together? Why do they do this? And then they're very scared. The child will be scared, or child will be in 10th class student sitting in 8th class student will show off and will be spoiled. So these classes are not good. Yes, these classes are not good for students who struggle in their routine mathematics, which is asked in class or done in class or asked in exams. So you people are the people who can grasp and do your routine mathematics quickly, and those exercises you do, similar exercises which you are doing. And then you look for more number of things, more number of problems. And that is where you see this Olympiad stuff. Okay, so you people are very special. And as I told you, Maths Olympiad, the problems which are supposed to be asked, they're very basic. And there are times when from a city, 8th class student has cleared Indian National Mathematical Olympiad, even 7th class student from Nagpur once, many times, sometimes from 2000. 7th or 8th class student has cleared in more Indian National Mathematical Olympiad, 11th, 12th, 10th, 9th, people know. So what is it? What is it that makes this Olympiad? And other Olympiads are not like this. Other Olympiads, math, physics Olympiads, and physics Olympiad, or chemistry Olympiad, they include many things every year. They may even include the latest invention in some way or other. But math people, they don't. Math people, they won't ask you calculus. If you know calculus, you'll be benefited. In a problem where calculus can be done by calculus, A, this student is not so good in that. A, this fellow did the problem and got the marks. What is it? So I'll give you one example. That is so that you should be at home. You should not laugh at 8th class students, 9th class students. Oh, this fellow, he will understand. And you should not be scared of 10th class students, lower class students. They should not be scared. It is equally poised. If the genuine paper is set in mathematical Olympiad, then everybody will be at ease and everybody is likely to pass or fail. So if you pass these exams, it is commendable. And if you don't, it is understandable. Sometimes what happens is, algebra is what connects you to Olympiads to your IIT-JEE. IIT-JEE has been raising standards of the physics, chemistry and maths for over 70 years in the country. Why? How it is raising? It is asking new problems, novel problems. And after 4 or 5 years, these problems come in books, board exam books, and this is how they become popular. And the standard goes up. So for over 70 years, IIT-JEE has been raising the standards of these three subjects in the country. Let me tell you, had ITD not been there, our standards would have been very poor. Some 25 or 30 this thing, whatever, CEOs of international, multinational companies are Indians. It is just because of ITD. And then Olympiads. So ITD has raised their standards, Olympiads have further risen. Okay? So now I'll just give you one example how this 8th class students can show up and pass, and others, even 11th, 12th class students do not. So let us see one example. So one year this question was asked. This is 5th degree equation. So it's a 5th degree polynomial. You know how many roots it will have? And then we warn you, I'm not well prepared. So you have to help me. Okay? So, and getting the correct answer for a given problem is your responsibility also. Okay, so if I commit any mistake, you tell me immediately. So this will have 5 roots: x1, x2, x3, x4, x5. And you are told the connection of roots with the coefficients. Correct? So some of the roots, for example, some of the roots will be what? In this case, 10. 0. Yeah, very good. And you can write 5. Correct? So the question which was asked is, find the value of okay. So that year, 2 8th class students, they got this right. Okay. Others also got right, but 2 8th class students that got right. So, and you know this, in polynomial algebra, you are told there will be 5 relations, and using them you can do this. So, would you like to suggest first step in this? So those 8th class students, they knew one thing very well. And this is what is called essence of the thing. You may know sum of roots is this, some product of roots is this, and then you may know many things. But the essence is not this. Essence is something else. Essence is not written in that books. So I used to complain to my seniors, so many things have not been written in these books. So those seniors, they say, if everything is written in books, the book will become very thick. So that is why many things are not written. Another thing is, authors when they write book, they may themselves not be knowing those things at that time when they wrote the book. So please understand there's a problem with the books that they don't tell you the full truth. They tell you some piecewise truth. Yeah, this is correct, that is correct, this is correct. But essence many times is missed. So those 8th class students, they knew the essence. So please catch the essence. That is very important. So what is the essence they used? They said if x1, x2, x3, x4, x5, x6 are the roots, x5 are the roots, then it must be this. Is this correct? Yeah. They just knew this. And they also knew this. They also knew this, that this is an identity. This is an, you put any value of x. Yeah. Hello? I don't know whether it works or not. Yeah, please. Yeah. Yes. And this is an identity, you put anything, x equal 1, 2, 3, 91, 7, you work here, anything. Correct. So what is the next thing which should be done? You can put any value of x if you like. And it will be correct. But you should put survey value which should help you. So what should I put? Yeah. Hmm? Say again. Okay, root 2i. Very good. Yeah. You put x equal to root 2i. All of you put this. And then put x equal to both sides. Then see whether you get this. So if you put this, so this is this to a 5, so this will be what? Root 2 to power 5 and I to power 5. And you know, they knew this. They knew what? I is equal to, and they knew this I square is what? Minus 1. This is the essence. I is this. You just need to know lessons. Solve it. Okay. So if you put this, so what happens? This is root 2 to power 5 is how much? 4, no? 4 root 2i. And this will be root 2i. And this will be something. And this will be what? Will it be minus? Yeah? And this will be root 2i. Okay, yeah, please do this. Hmm. So right, other side, yeah. Hello. Yeah, so this what? This will be, yeah, this will be what? Root 2i minus x1, root 2i minus x2, root 2i minus x3, root 2i minus x4, and root 2i minus x5. Correct? And then you put this minus this. Correct? And this will be what? Minus root 2i square and what? Minus, this will become plus, na? So plus x1 square. Is this correct? And similarly you can write. It's okay? So this into this. So what is this? This is minus, and this is x1 square plus 2. Minus minus will come, so 5 times it will come. And you multiply this, so this will be what? 1 plus 5 root 2i, correct? And this will be 1 minus 5 root 2i. Is this correct? So how much is this? This is p plus q, p minus q. So this is 1 plus, this is square, so this is, yeah. So 1 and this will be what? 5 square is 25 and 50 i's, correct? 50. And this will be what? And this quantity you can call as f. F. So this is what? Minus f. So the f will be how much? Minus 50. Is this correct? I don't know whether this answer is correct. You have to certify, you have to check. Okay? Correct? So what should be the answer? Minus 51? Correct? Okay? Now, what was the actual value? This is by the essence. But students who are taught more, who have practiced more. There's one more method remaining. They can at least one more. Maybe you, somebody sitting here knows one more. So according to me, one more method is remaining. So what is that? Which of course may be those it is not very natural. I mean, it comes by practice. But this is a natural solution. And believe me, these Olympiad problems are supposed to be set like this. If they are not able to set like this, then it's the failure of the examiners. Okay? But they want that students who are basic, who know essence and who can use the basic this thing. I mean, they want untrained students to qualify. Okay? So this is one example I have given you where 8th class students they have done this problem. 12th class students, let us see what they should do. And this is something called transform your equation, x equation to y equation. X equation to y equation. And if x and y equations are same, this thing called power, they are polynomial equation of same order, then same degree, then you will be successful. So what you say this, what this is y1, this is y2, this is y3, this is y2, and this is y5. So from x equation go to y equation. So what? And go and put this here. So this will be you right. Y minus 2. You take plus sign or minus sign. You have this freedom. And what? Okay. So this is what? Oh, sorry. This will be 5 and this will be Now what? So you have transferred the x equation to y equation. Now what you have to do is you have to get a 50-degree equation in y. For that, what will you do? Yeah? Square it. Yeah, square it. Very good. So square this up. So this will be y minus 2 plus y minus 2. Correct? And then this will be 2 and y minus 2 u. Is this correct? And is equal to what? So this. Now what you are supposed to find out? In this polynomial equation of 5th degree, you are supposed to find out the product of the roots. y1, y2, y3, y4, y5. So you may open it, you know binomial series, somebody might have done it. You can open this and you need not open this. So you need to know what important in the theory of polynomials. The product of the roots will be what? The last coefficient divided by the first coefficient and minus 1 to the power 5. Correct? So this quantity will be what? Minus 1 to the power 5. And the first coefficient will be what? 1 only. And constant term here. So constant term minus 2 to the power 5 is how much?
30 minus
30 minus 32. And then
minus 2.
This minus 2. And then this
Minus
16. No? So minus 1. Now I don't know whether I will get the correct answer. Have you done any mistake? So how much is this?
51 minus 2.
Minus 51. We should have got minus 51 and this is what? Yeah, minus 51. So we are getting answer as 51. And previously what we got?
Minus 2.
Minus 51. So they should we should sort out where is the mistake. Yeah, so this the lastly the roots of this equation will be what? The constant term and minus one, it starts with minus plus minus plus minus 1, 2, 3, 4, 5. Yeah, so it is minus.
There should be a plus one in the last.
There should be
Plus one.
no, that is okay. I mean this. Uh, yeah. So where is the mistake? Yeah, so yeah, we squared it, so it was minus 1 to square so plus minus. Or maybe you check this calculation, maybe the answer should be what? Both of them should match. You go home and do this. Okay? So, so I hope you have understood this method of transformation. Method of transformation is very powerful. Why? Because you may be asked this. I mean, you can be asked anything, no? Y1, Y2, etc. The sum of these, and which can come from here. Correct? So let us see this. The sum of the roots will be what? Sum of the roots will be minus times this coefficient of and then plus times and all those things. So you should try doing this. You should sort out whether the answer should be 51 or minus 51. Okay? So this. And this way you can be asked, for example, yeah, let us quickly do this problem. So they say find out this. X1, X2, X3, X4 are the roots of this equation, or say minus. So find out this, value of this. Now this question can be done by some 3-4 methods. And some methods will be longish, unnecessary. Some methods will be quick. Tell me if you get any answer. Yeah? Okay. So what will happen is this 7th class. Okay, just wait. F equal. Okay, maybe I should have given. Yeah, I think I should have given you this. If I say this is plus, so x is equal to. Oh, okay, you try to do this. x equal to yeah, yeah, please take this. Yeah, this will be better. Yeah, yeah, plus is better. Minus
minus
what? How did you do? Yeah,
sir, I transform this order and then I take one of the
yeah. Minus one. Yeah, so seventh, eighth classes will simply do this for this problem. What? So this is nothing but half times 1 upon x1 plus 1 upon x2 plus 1 upon x3. You look for such simplifications. Correct? So this will be what? Half and x1, x2, x2, x3, x4, x1, x3 upon what? x1, x2, x3. Correct? Now in the original equation, sum of the pairwise products is how much? Minus 2. And this thing is what? Minus 1. And this is half. So answer is 1 or minus 1? 1. 1 is correct? Yeah, so this half times this will be what? Minus 2. Correct? Because of course some of the roots will be 0. Some of the pairwise products will be this. What? Minus 2. And this will be minus 1. So the answer will be 1. Is this correct? Yeah. Okay, so this is one thing. You know, in this question, if x equal to 1 is a root, na, then you can find out other two roots. Correct? But that will be boring. If you find out one root is what? By remainder theorem, if you divide this by x minus 1, yeah? Oh, so question x cube plus 2x is this. Minus 2x plus 1 this.
After dividing,
After dividing, what do you get? Yeah?
x square
X
plus x
plus
plus x plus
plus.
plus
This also is plus. Huh? So what will happen? It will have it will have one real and two non-real roots. Is this correct?
no sir, x1 plus x minus
So it will have two roots, and those roots will be real or non-real?
non-real.
Non-real. Then see the roots will be roots of this will be what? Minus 1 plus minus 1 plus. Is this correct? First of all, is this correct?
Yes.
Okay. Then minus 1 plus minus what? 4. To be irrational, and it will be unattractive idea. You use these three, x1 is 1, x2 is this, irrational number, x3 is this irrational number. Not a good idea. Correct? And the transformation idea will be, you can say y is equal to what? You can convert it to, or say y is equal to, correct? So x cube will be what? So x will be 1 upon y minus 1 to power 1 upon 3. Go and put it there. Yeah, just do this. All of you do this. This is the method of transformation. From x equation, you get y equation, and if both of them are cubic, then you are done. Okay? So if you put it here, so what will happen? This will be This is 1 by 3, no? Correct? Then you have to say, can you just rationalize? Rationalize means the power should be integer. So what you do? You simplify this and take it there and go through both sides and get the equation and tell me what is the y equation.
So, 1 by y cube minus 8, 1 by y.
No, you write is a cubic equation, not 1 by y cube. Write y cube like that. So tell me what? It will be something like this, now y cube plus. Write it as a polynomial equation. Yeah?
8 by q
8y cube.
minus 8 by
Very good.
plus 1.
Yeah. So what will happen by 1 by 2 by 3 will be equal to what? This will be what?
So can you find the sum?
We have to find the sums. No? In this question, we have to find sum. The sum will be what? This minus times minus 8 upon. This correct? This is the method of transformation. And method of transformation, I mean, they can ask you some other this thing, this y1 by 2, y2 by 3, y1 by 3. Okay? It's a very powerful method of what? Is this okay? So convert your x equation to y equation and then get it. Okay? Okay, so this is one thing, conversion of what do you call it? This transformation of equation. Correct? Transformation of equation. So, yeah, let me tell you another thing. So, another thing is it is called careful algebra. Okay? So if you do careless algebra, you will get problems. For example, x plus. You have to solve this. Correct? You have to solve this equation. So what we will do, we will say, yeah, this is root x minus 2. We will square this, correct? So x minus 2, and this is what? So this will be x square minus 17x, and what plus? Is this correct? Yeah. Keep checking if I am committing any mistake.
Answer 66.
66. Okay, thank you. So what are the roots?
11 and 6.
So x equal to 11. So how many roots? 2 roots. Correct?
So, but one is an extraneous.
So now if you put this root into it, suppose you haven't checked, most of the students they don't check, they get excited. Oh, I've solved this problem. And they get excited. So some students will put 11 here. So this will be what? How much?
11 plus
11 plus 3.
40. And 11. And what other root is 6 plus? This will be. So this will be root and this will not be root. Fake root. It is not a root. Then don't for fake root. Not. No, it is not extraneous. It is not a root. Don't develop root for bad things. Okay, it will be the bad things. Okay. So, and then what? Yeah, let me also tell you. The essence of your algebra is this. Algebra, in algebra, when we are doing algebra or calculus also, we are actually trying to find out some physical fact, number. For example, we want to find out temperature, we may want to find out length, anything we want to find out, money, economics. So all these things should be what? Can you tell me? In mathematics, x is a variable, so y is equal to f of x. Y is equal to. So f y is equal to f of x may be hour-wise payment, correct? X is our number of hours, and f of x will give you how much money to be paid. Y is money, correct? So now tell me y equal to fx is going to solve your real-time problem. So what should be the property of a function? Y should be property of a function. Tell me, speak up. First, what it should be?
Every element of x.
He's saying increasing function. The function decrease also. Yeah. Okay, no. I think I'll just take. Well, this is the essence of mathematics. At your level, what is it? X should be real and finite. X should be real and finite. And Y should be real, finite, and unique. Real, finite, and unique. This is the. I mean, if I tell you, I'll give you 2 plus 4 rupees, I'm dying. I can never pay you this. Huh? I'll give you infinite money. I'm dying. I cannot pay you infinite money. So, fx indicates a physical thing, temperature, money, length, or any other thing. It should be real, finite, and very important thing should be unique. There shouldn't be any ambiguity. Otherwise, there will be fights. Correct? So please remember always, and you'll be asked this in interviews. What should be fx? It should be real, finite, and unique. Correct? So suppose we are measuring temperature of studying temperature of somebody with respect to time. Correct? Can temperature be like this of somebody with respect to time? Yes or no?
Yes.
Yes. So the same temperature can be achieved at many times. Is it okay? Can it be like this?
No.
Because at single time you will have 2 temperatures, which is wrong. Which is wrong. So this is not your function. This is not a function. Function should always be unique value. And in this case, what will happen is from here onwards, what is the temperature? It is this and this also. Right? So it should be your fx should be real, finite, and unique. And sometimes if it is not, then what happens is domain of a function is called this. All possible values of x for which the function is real, finite, and unique. So what are the values of x for which this will be real, finite, real?
0 to
0 to 1 is they should be all values. This is the condition. All values of x, if you say domain of this function is this. So all values of x for which this function is real, finite, and unique. So what are all values? Minus 1. Very good. Minus 1 to 1. So x. Now tell me this. Gx is outside this will be not real. We don't take that. We don't say extraneous or something. No, we don't take it. And then this. What will be the domain of this?
open interval.
Yeah. So minus 1 and plus 1 will 2. Other values are correct. And suppose we have this hx, h square x. Is it the function? Hx is the function? No. Ambiguity. And there shouldn't be any ambiguity. So it's not a function, it's double value. So what happens? It is not a function, but it is a curve. So functions are curve. All curves are not functions. For example, a parabola. It is not a function because for every value of x, it will give you 2 values of y. Correct? But it is a curve. That is true. Curves are not functions. Functions are physically important because you are going to determine something, you are going to pay people, you are going to These are temperatures, so they should be unique. Shouldn't be any doubt. Nobody can go to doctor and say his temperature is 10 or 110. No. Okay, so this is very important. This is the essence of real analysis, that what should happen? The function should be real, finite and unique, and x should be real and finite. X should be real and finite. Correct? So here what happens is, there is a very important rule in mathematics, which is this, that if you are squaring an equation or inequation, both the sides must be positive. If not, you declare. So what you should have done is, another thing is that you want real solutions. Always you will be asked to find real solutions. So what should happen? X minus 2 should be correct. Declare this. This is in ITT and Olympiad. Declarations are very important. Don't declare, you cannot solve problem. Declaration is a very important part of your solution. To declare this. Now you want to square this, so you declare 8 minus x is what? Then you can. This is called analysis. And once you have done it, you have to go and see whether there is any contradiction between the declaration and the analysis. So 11. 11 is greater than 2, but x should be less than 8, it says. So this will pass and this will not pass. Correct? So carefulness in this. Now, best thing is you should know the essence, know this rule. What? If you have squared an equation and both the sides should be declared what? Positive. And we are going to do arithmetics. We are not doing arithmetic, we are going to algebra. We are doing algebra. So in algebra, there are two kinds of quantities. Number one, they are definite. Number two, they are indefinite. Definite quantities are, they are always positive or always negative. Indefinite quantities are, they are sometimes positive, sometimes negative. For example, x plus 1 is definite or indefinite? Indefinite, because for so many values of x it will be negative. For so many values of x it will be positive. But x plus 1 is square? Definite. And minus x plus 1 square? It is negative definite. Correct? X plus 1 square is positive definite. X plus 1 is indefinite. Correct? So what should happen is 8 minus x is indefinite. That is why you have to declare it what? Positive. Now suppose you have this, you want to solve this equation. What? Where is the chalk here?
Sir.
Now suppose you have to solve. So here you have to so please see. Can you tell me this? 11 will be actually 11 will be, you can check later. 11 will be, some poor students they say, yeah, this is okay. What is the problem? This is 11 and this is root 9 and this is minus 3. Correct? So please notice one important thing, that x square is equal to 9, means x is 9 to the power half, and this means it has got two branches, plus minus root 9, and this plus minus. Okay, and you can also do it like this: x minus 3, x plus 3. Correct? So what are the roots? So what is plus minus? Roots of this equation, or value of this 9 to the power half is plus minus 3. Root 9 is not plus minus 3, it's a misconception. Root 9 is 3. Root 9 is, so those poor students they tend to think like this. Is it plus minus 3? It's okay. No, it's wrong. So x equal to 11 will be root of what? This equation. Correct? Because you will do this. This will be what? It will become what? X minus 8. And in order to square this, you will say So x should be greater than 8, then 11 will be the root. Correct? So if something is written as root, this examiner has chosen plus sign, it is plus 1. He has chosen minus sign, it is minus 2. There is no choice there. Correct? Now what? Suppose you are solving this question. What are the values of x? Yeah? X equal to how much? 11. Correct? Now we want to solve this question. No solution. Leave it. Leave it. You start leaving things. Start leaving things. Leave it. You cannot do anything. No solution. Correct? Don't square forcibly. You cannot square. And because minus 3 is minus 3, we cannot declare it positive or negative. But algebraic expressions can be declared positive or negative, correct? But we cannot declare. So please have a habit of leaving it. Correct? This cannot be squared. Leave it. Then many times. So this is this expression. If this expression is definite or indefinite, x, y, z are real. Positive definite. And what about this?
No.
This is indefinite. So these indefinite expressions are very interesting. If they are set equal to 0, you get a good number of roots. If an indefinite expression is set equal to 0, you get good number of real roots. And if it is a positive definite or is if a definite expression is set equal to 0, you don't get roots. Or you get boring roots, some roots. So if I set equal to 0, what are the roots? All of them 0. Correct? And that is called trivial. If positive, if definite expressions are set equal to 0, you tend to get trivial. But if it is indefinite expression set equal to 0, you get good number of real roots. You get Pythagorean difference. Right? So the and this will method is to see, look at. Is it definite? Definite, the whole expression definite. If it is set equal to 0, it cannot have real roots. It cannot have real. It may have trivial roots. And when x is equal to 0, so instead of solving that equation, you can just tell the second. Not have roots, correct? And then real roots. Okay? So this is very important that this equation will have many roots, you know, Pythagorean difference, but this will not. But sometimes what may happen is you may have this, and such questions are asked. Correct? So this is what this is positive definite expression set equal to 0. So what are the roots?
It's equal
It's
to
equal to
5
y
and
is
z
equal
is equal to 4.
Yeah. Despite there is one equation and there are real roots. So these questions are asked. And if it is opened up, then it will be completely difficult for students to write it like this. And if you write like this, the roots are, and it will be called trivial. It will be called trivial. So, okay. So sometimes yeah, it is interesting that positive definite expression has been set equal to 0, then it will tend to have trivial roots and that will be useful. Okay? Useful. Correct? So this. So what? You be careful in solving equations and don't do this one. Don't put let's see. Yeah, maybe we do. Yeah, let us do one more question. Uh, yeah. Find all roots of this equation. No roots, yeah. So you can say if you square this, so if you square this, you will have to calculate this, correct? So this will be 16 plus x square minus 8x. So this cancels, and this is what? 13x, and this what? 65, huh? Correct? So x is equal to 5. Yeah, so you feel very excited. Yeah, so, and go back and put in 5 here. So what will happen? This will be, if you put x equal to 5 here, it will be this, na? But root 1 is not minus 1. Root 1 is 1. So this is not possible. No solution. Correct? No solution. You can be asked such questions. So in these two exams, IGJE and Olympiad, you may encounter an equation. It may have more number of roots, you may get less. It may have less number of roots, you may get more. So you have to be careful. You have to be careful. Okay? So yeah, let's quickly solve this problem, which is to enjoy solving this, find all roots of this equation. Just solve this equation. Find all roots of this equation. This cube. Yeah. X equal to 0. Oh, but there's some other roots also there.
No,
Who is there?
that is not.
Why?
Because 1 minus x is greater than equal to 0, but 2 will give us minus.
Okay, so please see this in your journey of solving this equation. You will get x equal to 0 and x equal to 2. And x equal to 2 will be a double root. But if you see just above that, you must have squared a quantity without declaring. Suppose 1 minus x you have to square. 1 minus, is it 1 minus x? What you are squaring is 1 minus x?
Yes.
So you have to say 1 minus x is positive. That means x is less than 1. When you get root x equal to 2, it will be wrong. So this equation has got only one real root, 0. And this question has come from a serious book of mathematicians who believe you get people. And they have given the roots of this equation are 3, 0, 2, and 2. So they were enthusiastic to explain to students that there are some double roots. And in that, they have not realized that though the double root is, they are not roots. So if such serious people, they commit such mistakes, then what about you? Do you care? Very serious people, they have written in their books that the roots of this equation are 3, 0, 2, and 2. It's wrong. Correct? So you don't commit such, and you just put x equal to 2, it doesn't satisfy. This equation, nobody can cheat you. You just put the value x equal to 2, it is not right. So remember this question, and this comes from a very serious book. Even those authors have committed this mistake. So be careful. Okay? Okay, so this. So I hope you will be careful in tackling these equations. Another thing is, yeah, just solve this problem. Yeah, find out value of x. K is some real number. Find out. Yeah. So x is equal to what? So x plus 2 by 4 equal to 1 upon k. So this is correct. Is this the full answer, or you would like to write something?
Yes.
X not
X
equal to
not
minus
equal to
2.
0.
X not equal to
Minus 2.
what else?
K
A not equal to 0.
Yeah, it is examiner's responsibility to tell k is not equal to 0. If examiner has not said, then you say it. Examiner will expect you to say it. And don't say x cannot be minus 2. Say k cannot be minus. K cannot be. So prevent, the rule is prevent your answer from becoming infinity. If you get infinity as an answer, it is not an answer. As I told you, infinity, suppose is the money you will pay to somebody, you cannot pay infinity to anybody. So infinity is never an answer. So you prevent your answer from becoming infinity. Then next rule is more interesting. It says, okay, you can do one more problem quickly, yeah. Yeah, let us do this quickly, yeah. Find all roots of this equation. Yeah. X equal to how much?
X plus k by
A plus
3 by
A plus 3 by 2. Do you want to say some more things? We should say x not equal to
X not equal to K. X not equal to K.
X not equal to K.
no. This will not be the answer. What else? So in your options, this will be one option. This and one more statement will be option number B. Then option number C is this and two more statements. So what is the correct answer? Tell me, anybody. So you do this while solving at the top of this, you make a practice. Prevent your analysis from division by zero. Division by zero should not occur. For that, you make declarations and come back to the declaration. If you don't declare, you forget. If you declare and come back, don't come back, no use. So you have declared this, and you have got x, then you say it should not be equal to k. So k plus 3 upon 2 should not be equal to k, that means k plus 3 should not be equal to 2k. That means k should not be equal to minus 3. Is this correct? This you put here. And what? One more thing. So say this. So this should not be equal to 1. This means k should not be equal to minus 1. This will be the correct answer. Okay? And don't say that that should not be this. Is this like a sermon or like a suggestion to the examiner? Okay. To remove k equal to 1 and k equal to x equal to 1 and x equal to 2. Who do that? The condition will come out k, the parameter, in terms of which you have written your answer. This is your duty to tell the value of k, not x. X you have said. X is what? K plus 3.
It should be k not equal to 3.
This, yeah, I don't know. Should be. Yeah, not plus, yeah. Thank you. Okay? So this. Okay, now next thing. Be very careful with the absolute value. So mod x is equal to what?
X if x is greater than 0.
Yeah, it's a conditional function. It's a two-piece function. And over is going to say, yeah, mod x, I know. This. It's wrong. X is not plus minus x. It is conditional. X is mod x is plus x if x is positive, and it is minus x if x is negative. You can put equality in. It's a two-piece function. That is depends where you are. If you are on positive side of x, it is x. When you are negative side of x, it is minus x. That is why it is always positive. That is why it is always positive. So please see this, and those of you who know quadratic, this means y is equal to x line. Y equal to x line is this one, but we will rub off. So this is valid only for x greater than 0. This is minus. We will rub off this. So it is a v-like function. Is a v-like function at 0, correct? So this. So wherever mod x comes, you will have to rewrite your equation 2 times. First you declare x to be positive, then you declare x to be negative. So for example, this. Suppose you have to solve a very simple thing. Mod x is equal to 5. So you say first case, x is positive. X is rewrite this. And this is your analysis, and this is your declaration. Yes. Declaration says x is positive, and analysis says x is 5. Yes. This is the answer. Then second case will be what? X is negative. If x is negative, this will be written as x will be equal to what? This and this, yes. So what is the solution? X equal to plus minus 5. Correct? Okay. Now tell me one very important question I am going to ask. Or okay, let us do this. Let us solve this equation, the quadratic equation. But mod x has come, so we have to rewrite it. So first case, when x is positive, so this will be what? Correct? So if you solve this, so what are the roots? Minus 3 and minus? No. We don't admit them. Correct? Second case. X is positive, they are negative. When you say X is negative, then it will be written as what? Correct? And what are the roots? This is no. If the roots are positive, this equation doesn't have any real roots. Correct? And you could have said this even otherwise. How? This expression is positive, definite. How can it have roots? It cannot have real roots. Correct? And if you make it minus and do it, so this will be what? And this will be yes. Yeah. And then this will be minus yes. So it will have 4. This equation will have 4 roots. This correct? So please remember, when mod x comes, you have to rewrite the equation. First you declare x is positive and you write accordingly. And then say x is negative. Now let us see this. Now can you answer this question? Mod of 4 minus 5 is equal to what? 1. Any other answer? There can be a better answer. And if you answer that, you will be able to solve a lot of problems. Mod of 5 minus 4. Anything else? No, 1 is correct answer, but it is not so correct. 1 is like this memory. Yeah, it's 1. No, minus 1 also is not very good. No, what I'm saying is, it is like this. You are taught like this. So this what? Mod of minus 5 or something. That means you ignore sign. Ignore sign. And here it is very simple to ignore sign. You are not doing rubbing off. Ignore. Don't look at it. But we are in mathematics, we have to do something further. So, mod of 4 minus 5, if you say it is 1, this is correct. We will say this it will be minus 1, so ignore minus 1. You are not going to be empowered. For being empowered and for being able to solve many problems, you should say this is 5 minus 4. And if you say this, you can solve a lot of problems. Otherwise, you say, I ignore minus sign. Ignore minus sign. Don't look at it or just rub it out. That means you have to rewrite your expression. You rewrite your expression so that it is automatically positive. You don't have to give instruction to ignore minus sign or rub off minus. Everybody will do this only. Why? Because you have written it correctly. We are going to solve a very difficult problem just based on this idea. What? Whenever you see this mod sign, you have to rewrite your equation. That is why I said mod of 4 minus 5 is 1. But if you say mod of 4 minus 5 is 5 minus 4, that means you can solve a lot of problems. You know what is to be done. So let us see. So this how this minus sign is ignored or rubbed off. It is by mathematics. 4 minus 5, 5 minus 4. So you have to rewrite. This is very important. You have to rewrite. Correct? So now let us see this. It's a very difficult problem. Okay? Now, these are both absolute value function. So absolute value function is this. This is called MOOP. So this is equal to x minus a when x is, and this is equal to minus times x minus a when x is. Okay? Now what? Now it is going to be a method. You put these nodes, they are nodes 1 and 2. How many regions are created? 1, 2, 3. So region number 1 is what? X less than. It is optional. You can include 1 here or 2. Now you see this. How do we practically do this? So just put this. Take a typical number here, say 0. If you put 0, this is negative, na? The side thing is negative, you will have to supply a minus sign. So you write this. That means you have rewritten it correctly. Correct? Now you have to rewrite this. So x is equal to 0. If you put this negative, so you will have to supply a minus sign. Okay? Now solve this. So this is what? Minus 2x plus 1 and plus 5. So this is minus 2x is equal to what? Plus 1. And this is plus 4 equal to 3. So minus 2x is equal to 3 minus 5. So what? X is equal to how much? Hello? X is equal to 1. So this is the spirit that this you have to rewrite. And it depends where you are standing, where you have declared yourself to be. We have declared ourselves to be what? X less than 1. So that is why we are. Now we have got an answer. Can we take this answer? No. It may be answer, but it may be some other. Correct? Since we did not include, if we include this, then we can say yes, this is the answer. It is in our hand. Including a point is in our hand. Whether we include this point here or there. Now next. Yeah, next let us see this. Next, second thing is region number 2. And what is region number 2? Correct? So from here to here. And 1 is included here. So now what? So we have to write. Now we take a typical number here, say 3. So 3 minus 1 is positive, na? So we don't have to supply anything, any sign here. Correct? Yeah? Yeah, let me write. So this now. Now if I put here x equal to 3, so this is negative. So we'll have to supply a minus sign, correct? Now this is what? Now in very interesting situation, x disappears. Now x disappears, then you should say, oh, the solution is infinite, there is no solution. If x disappears, that means the whole declaration is the solution. And look, if x disappears, then check whether whatever is left is true or false. It's true, 3 equal to 3. So that means whole declaration is the solution. One also is a solution. Correct? Yes. True. Correct? Now next, region number 3. X is greater than, can include it here. So this will be what? You take a typical number here, 5. 5 minus 1 is positive, 5, this is positive. They will be written just like that. Correct? This is equal to what? So this is 2x is equal to 8. Yes. This simple equation has got infinitely many roots. What are they? All numbers from 1 to 4. All numbers from 1 to 4. Root 15 is a solution?
Yes.
Root 17? Correct? Root 2 is a solution?
Yes.
Pi is a solution of them?
Yes.
Pi square?
No, sir.
1 upon root 2?
No. No.
No. So all the solutions are this. All the solutions, include all the solutions. All numbers from 1 to 4 are the solutions. Suppose you are asked to write an algebraic equation, by the mini roots. Quadratic equation they generally don't have a price. But this equation will have primarily many roots. Correct? Now let us see this. So this is how you should solve. You write all node points, create all the regions, go region by region, rewrite the equation, get the solution, and check whether that is admissible or not. There may be lengthy problems. To this one. Suppose there are two nodes, so how many regions are created? Three. And if there are three nodes, then four and so on. Be patient. Okay? So this. Okay. Suppose we want to solve this problem. Yeah. Suppose we want to solve this problem. So how many nodes are there? Two nodes. One and two. So if we say x is less than 1, so here we take typical number 0. So this will be written as -1 minus x. Na? And this also will be written as what? This is 2. Correct? So you take a typical, so another one region is this, another is this. Take a typical number. What? So from 1 to 2, split take 1.5. This will be negative now, so this also. So what is the solution? So what is the solution? Is there any solution?
X equal to 3 by 2. For
X-
second reason.
X equal to 3 by 2 is the solution.
For second reason.
For second?
Oh, sorry, for
Yeah,
second
for
reason.
X, yeah. So you write this. Now you have to say, correct? So this will be what? So if you take 1.5, which says this is positive, so it will be like this. And this will be what? It will be written minus like this, correct? So this will be what? X minus 1 is equal to x minus x plus 2. So 2x equal to 3, so x equal to what? 1.5. 1.5 is in this? Yes, this is the solution. So what is the solution? Yeah? It's correct? So solution is what? X equal to 1.5 or 3 by 2, correct? Now I am going to do it by this problem like this. What? Okay, this problem. Let us do this problem. So let us solve this problem. Hmm? They are same. So there is a tremendous essence, and this essence is very important. What is that? This. So poor students say, yeah, I know this, which is wrong. And in these exams, if you don't exercise this, your answers will be wrong. You exercise this. So you yourself will realize that this equation is nothing but so if you have a perfect square inside, what is x minus 2 whole square? Square root is mod of x minus 2. It's not x minus 2. Or it is not plus minus x minus 2. It is mod of x minus 2. And what? The answer will be again this. But I wanted to realize this. I wanted you to realize. Can you do it by some other method? Not by this.
We can also take root of x square minus 2x plus 1 and then Square root of
Can you do it by some other method other than this mod x? Yes, square it. Both the sides are positive. Very simple. They square it and check. Square both the sides. We don't be so much scared. Oh, you cannot. When you square it, both the sides are positive. This is positive, that means this is positive. Square it, and whatever you get will be right. Check. So what answer you get? 1.5 once again. Correct? So this. So yeah. So this, I don't know, sometimes some students they think, okay, we have been told today, so today we will do this. Okay. Always you do this. What square root of, suppose square root is in higher, suppose you are solving this problem, find square root. And ITD deliberately will ask every year one or two questions between calculus, what will be whether you are exercising this, then yes, you get correct answer. If you're not, then you get wrong answer. Correct? So this. Now this problem, how will you solve this problem? Yeah. So you simply say this is x minus 1 or x minus 2. Is this correct? Yeah. Check whether there is any solution. And if you don't do this, this will be very, very lengthy. Now solve this. I also don't know that you have to do so. So what you will have to do is this. You make this 1 and you is it 2. Correct? So 0 to 1.
x is equal to 0 and b.
So this will be what? This will be continuous. So this will be x minus 1 minus x. Correct? And this will be plus minus x minus. So this will be what? 2x. Yeah, so plus 1 and plus 2, so what? 3. So x equal to 0 is the root. Yeah, x equal to 0 is the root. Yes.
Yes, sir.
Yes. And we put it there. Now let us see the next other root. Other root is what? Yeah, from 1 to 2. So when you are in 1 to 2, so this will be what? X minus 1 only, and this will be plus minus x minus 2 equal to 3. So this is 1 plus. All numbers from 1 to 2 are the roots. How many roots these are? These are infinitely many roots. Yeah. Yes? Oh, we started at 11:50. Please let it be 11:50. Yeah. We will continue till 11:15. Yeah. Huh. Yeah.
X minus 1.
Sir, minus 1 plus 2.
Oh, sorry, sir. This is minus 1 and this is. Oh, so then no.
So no roots.
Yes. Correct? Okay, now we are going to do this inequations. We are going to do inequations. Yeah, we are going to do inequations, and in equations, what is very important, the point which is very important is inequation. The essence is this: inequations are satisfied by what? Only real numbers. Complex numbers do not enjoy inequality. Those two complex numbers are there. We cannot say Z1 is greater than Z2. But if there are two real numbers, they are unequal, then they are automatically one of them is lesser, one of them is greater. So please remember, inequalities are satisfied only by real numbers. Okay? So, and another very important thing is, so we want to solve this. So we want to solve the real roots. We declare x minus 2 is positive. Then we will square both sides. Can we? Yes. So x minus 2. So this means what? Then we plot this. This means x is greater than 2. And if you want to include 2, then put a dot there. Correct? And what? X is greater than 11. And see where is the overlap. Where is the overlap? So what is the overlap? So x greater than x belongs to what? 11 to. Is this correct?
Open interval.
11 will satisfy this lab. Because equality is not there. Correct? Now you tell me this. What is the solution? X greater than? X less than 5 is the correct answer. Is it correct? Yeah, so what is the answer?
X less than equal to 5. X less than equal to 5.
This is the declaration, and this is true.
So equal to what? As
Equal to is small. First, we concentrate on. Yeah, equal to what? Positive number is always greater than negative number. This is true. So the whole answer, as he said, very good. X is less than 5, less than or equal to 5. Correct? Now let us do this. Solve this. Not possible. Positive quantity cannot be less than negative. So, when you are asked to solve a problem, that the impression is this: you get going, you start doing. You should do something. In these exams, sometimes you just look at the school and take the class. So no solution. Correct? Now one more, just let us say. Yeah, solve this. So your first declaration should be correct, and then you can of course square this. So this is
three seven. Open.
so now this. So you plot this. X is greater than 3 and x is less than 7. Is this correct? And this. So what is the answer? Answer of this x belongs to 3 to 7. Whether 3 we can put, if you put 3 here, no. we cannot include 3. So this is 7 can be included here.
Yes.
Yes. This is the answer. Okay. So this. Okay. Yes. Now you see this. So what happens is in inequations, you will be required to do inequations very many times in Olympiads, in ITJ, in board, in other exams. In fact, uh, students who have passed engineering and wrote management exams, their ITBs of those questions are asked here. Inequations and absolute value function, etc. They are asked even in management competition. They are so interesting things. Okay, so yeah, now let us solve this problem. So what happens is inequations are very difficult. I mean, inequations are very tricky and I feel very tense, very nervous. Okay? So and you should also, and poor students they don't feel nervous. They say, okay, what inequation? Let me see. They'll say yes, this is 2x minus 6, and this is 2x and 7. So they will say what? X is greater than 7 by 2. This is the problem. Poor student they do it like this. Now, how it should be done? Let us see. So, okay, so let us see whether this answer will stay or not. It may be partial answer, it may be wrong answer. We don't know. So what happens is, if you want to solve this problem, you have to do cross multiplication to get case number 1. As she said, since this is an indefinite quantity, you are multiplying it to the inequation. So if you multiply your inequation by a positive quantity, sign of inequation doesn't change. If you multiply your inequation by a negative quantity, it changes. Sign of equation, inequation changes. And if you multiply the inequation by indefinite factor, you should not. And if it is indefinite factor, you will have to make cases. So we make case. Case number 1. So if it is positive, you do this and you will get this. Right? Now you see this. X is greater than 3 and x is less than 3 by 2. So 3 where is 3? So this is, suppose this is 3 and this is 3 by 2. X is greater than 3 by 2. So what? X is greater than 3, x is greater than 3 is here, and x is greater than 3 by 2. So what is the overlap? X is greater than 3 and x is greater than 3 by 2. So what is the answer?
X belongs to 2.
So the answer is x is greater than 3, isn't it? Correct? Or x belongs to 3 to
Sir, what's the first condition?
36. See this. Hello. See this. So you have to take the overlap of these two things. What? X is greater than 3 and x is less than. No, sorry. X is greater than 7 by 2. Is this correct?
Yes.
So for 7 by 2, I am very sorry. 3 by 2 is this. Both here. Sorry. So this x is greater than 7 by. So now you do this. So x is greater than 3 and x is less than 7 by. So what is the answer?
Sir, x is greater than 7 by 2.
Oh, x is greater than 10. So what we do is, what x is greater than 3 and x is greater than 7 by 2. So where is the overlap?
7 by 2.
Yeah, so that funny answer stays. That funny answer stays. So, but that may be correct. That if this is more correct and this is what is required, case number 2. Case number 2 will be what? X minus 3 is negative. Hello, declare x minus. So whenever you are cross multiplying by an indefinite factor, you have to declare this. Once this is positive, once this is negative. If it is negative, then what will happen? The sign of an equation will change. This, correct? So this will be, and this will be, and this will be. Now you take this x is less than 3, and this what? X is less than 3, 7 by 2, 3, 7 by 2. So what is the overlap? X is less than. Is this correct?
Yes.
So the net answer of this problem is x is less than 3 or x is greater than. And if you do hanky-panky algebra, then you will get this. You are getting this, but this is not the full answer. So this is called the correct cross multiplication. Okay, by making cases and this declaration and this called analysis. You take the overlap, then you are right. Then only you are right. So this is the correct method, and you should be doing this. Okay. Now there is an alpha beta method, which is this. So suppose this is alpha, this is beta. So if alpha beta is greater than 0, or alpha upon beta is greater than 0, or beta upon alpha is greater than 0, this means what? This means this what? Alpha is positive and beta is, or alpha is negative and. So once you do this, you will be able to solve this problem. So this will be alpha is greater than 0 means x minus this. And what? X plus 7. So this x is greater than 2 and x is greater than minus 7. Correct? So this. So what you are getting? So if you plot this, x is greater than 2 and x is greater than minus 7. So this is the overlap. So you net you are getting x is greater than. This is your net answer. Now you exercise this. So x minus 2 is, and what? X plus 7 is what? So x is less than 2 and x is less than minus 7. So this is x is less than 2 is this, and x is less than minus. So what is the answer? X is less than
minus 7.
So it says the answer of this question is x is greater than 2 or x is less than. This is called alpha beta method. If you have solved this question, you have also solved this question. And what? All these three equations will have same answer. Correct? This is okay? This is alpha beta method. Okay? Now what? Similarly, you can do this. Similarly, let us do this. Yeah. What is it? Alpha beta is negative, or alpha upon beta is negative, or beta upon alpha is negative. Correct? Hello. So suppose you do this problem. This is alpha, this is beta. So if you do this, now this means what? This means alpha is positive and beta is negative. Correct? Or alpha is negative and beta is positive. And whenever you have or, so this means union between them. And means overlap. And means overlap. So suppose you want to solve this problem. So this will be what? Case first, case second. x plus 3 is positive and x minus 9 is, so this x is greater than minus 3 and x is less than, see this is minus 3 and x is less than 9. What is the answer?
X belongs to minus 3 to 9.
What? Minus 3 to, and you will see that this will be null. There will be no overlap. So some of you must be doing this very quickly and do it correctly. Even if you take time, but your answer should be correct. Okay? So just we can solve these problems graphically, and this will go a long way with you. This is the last thing, then we go further. Okay. So you call this as f of x and find out what is f minus infinity, whether it is plus or minus. Then plus. So if we put minus 10, minus infinity is minus big number. Minus 10, minus 10, it will be positive number. This means this curve will start from minus plus coordinate. Correct? And these are called nodes, minus 3 and what? 9. So the curve will start from here, it will come to the node. If the power of the node is odd integer, it will cross. And will go to next. And if this power of this also is odd integer, then you explore those parts of the curve where y-axis is positive. The y-axis, correct? So where is y-axis positive? No, negative. Sorry. Should have been what? Negative. So where is curve below y negative? Curve is negative from here to. That is why this answer is minus 3 to 9. Minus 3 to 9. Is this correct? So this graphical method will go a long way with you. So let us just quickly do one more problem. Which is so what you do? You multiply by x minus 1 up and down. And this is positive, definitely you can transfer it here. Correct? So you say gx. So gx minus infinity is what? Minus or plus? Plus. So this curve also will start from minus plus coordinate, and this will be 1, this node, and this node is minus 7. So this will start from this coordinate to come here, and this power is 1, this also is 1. It will cross here. Correct? You are supposed to see where this curve is positive. Curve is positive here and here. So what is the answer? Minus infinity to
Minus 7.
union 1 to, and just one more. Suppose your question is this. Graphically you can do just like that. How? This x. Now tell me this. H at minus infinity, is this side positive or negative? Huh? Negative now. So this will start from minus coordinate. So this from here. And what are the nodes? Minus 1 and minus 7. It will start from here and all of them are odd. So it will go here, here, and here. Cross everywhere. And now you explore where is this curve positive? It is positive here, here. What are the answers? Minus 7 to minus 1 and union 2 to. Okay? And just one more and then we. It is this. Yeah, we want to solve this problem. Hello, we want to solve this problem. So we'll say this is hx or px. So what is px minus infinity? positive. So this also starts from minus plus what? Okay. So this will start from this. Now what are the nodes? Nodes are 2, 3 and 5. So it will come and go to this node 2 and this power is 1, so it will cross. But the moment it is 3, it will come back, touch and come back. When the node is, this power is even, integer. It will touch and come back and again it will go. Now where on it is positive, so it is positive here and here. Correct? So the answer will be what? X is greater than 5 or X is less than -2. Correct? This method will go a long way with you and many times you will require to solve. We do one or two more problems after the break in the next session. And then, yeah, you can ask your question in the next session.